In this presentation, I'm going to talk about bridging local-scale water resource operations to a river basin economy to inform decision-making about sustainable water policies. My name is Leila Eamen. I'm a postdoctoral researcher at the Global Institute for Water Security at the University of Saskatchewan in Canada. This research and study is focused on the Saskatchewan River Basin, a multi-regional river basin spanning across the Canadian prairie provinces. This large river basin is mainly located in Alberta and Saskatchewan provinces, with a small portion in Manitoba. Water has been traditionally allocated in this river basin through a licensing system on a first-in-time, first-in-right basis. But since 1980s, Saskatchewan from the three provinces has changed this licensing system, and now they decide to issue new licenses based on their own terms and conditions and case specifically. The Saskatchewan River Basin is facing water management challenges. To name a few, I can mention water over-allocating challenges in upstream Alberta that prevents water authorities from issuing new licenses in some subbasins of the South Saskatchewan River. Also in downstream, the Saskatchewan River Delta has been facing several water quality and water quantity issues, mostly felt by the indigenous communities living there. And yet, there is need for more development in some other parts of the river basin. For example, need for more irrigation expansion in the province of Saskatchewan. To deal with all these and allocate water among competing users more sustainably, we first need to understand the consequences of our water allocation and management decisions from different perspectives. This motivates us to investigate the economic consequences and impacts of not only our water allocation decisions, but also other external drivers such as climate change and socioeconomic development on different parts of the Saskatchewan River Basin in this study. So the common practice in evaluating the economic impacts in water management studies, basically from an engineering point of view, has been focused on estimating the amount of production, for example, agricultural production under the changing conditions, here water availability, for example, and then multiplying this amount of production by an average market price. While this is a helpful approach when we are dealing with a river basin consisting of one region and with one directly water using sector, which is the economically prominent sector as well, it might not be as effective in case of multi-sectoral and multi-regional river basins. This is because different industries are economically interconnected. So if we change something in one sector, for example, if we change water supply to one sector, the economic impact of this change does not remain in the same sector. It propagates through the purchases of other sectors from the output of this first sector, not only in the same region, but also in other parts of the river basin. So we need an economic model that helps us capture these economic interconnectedness to estimate the not only direct economic impacts, but also indirect economic impacts associated with these interconnections. The engineering-based economic assessment models and approaches only account for directly water-using sectors, and they cannot capture these economic connections. So in the case of a river basin such as, for example, Saskatchewan River Basin in this case, where the directly water using sectors are responsible for almost 30% of the economy, even if we have all required data at a necessary scale to include all these directly water using sectors in our engineering-based economic assessment models, we still may lose the remaining 70% of the economy, because these models do not capture the interconnections between directly water users and indirectly water users. To deal with this challenge and to address this challenge, we developed an integrated hydroeconomic model here. This model includes a water resources system model that is developed in MODSIM and captures water resource operations at local scale by including reservoirs, diversions, and water allocation priorities, and it also covers the entire river basin. The model also includes an economic component, which is an interregional supply-side input-output model, or in short, an ISIO model. This model captures the intersectoral and interregional connectivity that we talked about by capturing trade flows among different sectors and regions. The model also relates water supply to economic production and reconciles hydrological and administrative boundaries, meaning that the model is capable of generating results at both sub-basin and provincial scale. Different submodels have been developed in MODSIM to simulate water resource operations in different parts of the Saskatchewan River Basin. For example, here is a snapshot of one of the submodels developed for the Saskatchewan sub-basin in Saskatchewan. This is a node link network where nodes represent water resource or demand sites, and links are carriers that connect these nodes. For example, here river reaches. Each of the submodels of the Saskatchewan River Basin model is connected to other submodels through the flow that it receives from upstream submodels or the flow that it passes to the downstream submodels. So this certain specific submodel that is shown on the screen now receives a flow from two upstream submodels and passes flow to one submodel on its downstream. The economic model here is an ISIO model, as I explained before, and this model is developed using economic input-output tables and a system of linear equations. Economic input-output tables represent inter-industry transactions among industries as producers and industries as consumers. Also, final demands are presented in these tables. Final demands are parts of output of those producer industries that go to end users like households or governments. The input-output tables also include value added for different industries like wages or capital. And we can extract total outputs from these tables, from these input-output tables. In addition to the input-output tables, we need a system of linear equations to develop ISIO models. These equations relate the total output to the total value added with the help of a matrix that comes from inter-industry transaction part of these tables. Now let's see how this integrated hydroeconomic model works. Different scenarios that we want to investigate are first simulated in the water resources system model, where the MODSIM model estimates the sectoral water supply under those scenarios. These water supply data are then entered into the economic model, and the ISIO model estimates the corresponding sectoral and regional production and GDP. By comparing these economic indicators with the same indicators under the baseline scenario, we can estimate changes in sectoral and regional gross output and GDP under the scenario at hand. Now, to showcase the performance of this integrated hydroeconomic model in evaluating the economic impacts, let's have a look at the application of the model in estimating the economic impact of an irrigation expansion project. This is an irrigation expansion in South Saskatchewan, in Saskatchewan, announced by the government of Saskatchewan, and it's going to irrigate 460,000 acres of irrigable lands from Lake Diefenbaker. So we used the integrated hydroeconomic model to evaluate the economic impacts of this irrigation expansion on different sectors and different parts of the Saskatchewan River Basin. Here are some results. Changes in sectoral gross output in the Saskatchewan River Basin as a result of this irrigation expansion are shown here. As can be seen, almost all sectors benefit from this expansion. Irrigation sector, most of them all. But also among other sectors, you can see that manufacturing benefits more than others. And this is because manufacturing includes industries such as food processing industries that are directly connected to the agricultural and irrigation output. The only exception here is hydropower. This is because when we supply more water to irrigation in upstream regions, downstream hydropower loses a part of its water supply and consequently a part of its output. So here you can see that when we use this integrated hydroeconomic model, we can see the distribution of economic impacts among different sectors. And also, the results show the potential trade-offs that may be there among different sectors. Here, the trade-off is between hydropower and irrigation. And here is the spatial distribution of changes in regional gross output. As can be seen, the economic impact of this irrigation project on different parts of the Saskatchewan River Basin are shown here. As expected, the region where the irrigation expansion is happening benefits the most, but almost all other parts of the river basin are benefiting from this expansion, even the upstream parts of the river basin, of course, to different extents. The only exception here is the most downstream part of the river basin. The reason is that in this part of the river basin, the only directly water using sector is hydropower. And as I explained in the previous slide, when we supply more water to irrigation in upstream regions, and hydropower in downstream regions loses a part of its water supply and consequently its output. Again, these results show that the integrated model can help us understand the distribution of economic impacts across different parts of the river basin and the trade-offs that might be there under each scenario. With this, I would like to wrap up. The integrated hydroeconomic model can help us understand the short-term direct and indirect economic impacts and the distribution of economic impact across different sectors and regions. So we can see how a change in water supply to one sector in one part of the river basin might affect other sectors in the same region, but also different sectors in other parts of the river basin. Here are some references that I used in this presentation. And feel free to contact me in case of any inquiries about this research. Also, you can always find the latest news, publications, and presentations about my research on my website. With this, I would like to thank you all for your attention.